Hello, and welcome back to another installment of the Math Made Easy series, also known as the Make Math Make Sense series. And in this series, we simplify potentially complex topics that students might find confusing, um, and hopefully explain them in a way that's easily understood. And in this installment, we're going to be talking about derivatives. And honestly, when I was preparing this video, I was I was thinking about what the best approach would be in order to try to simplify this. And what I think the best approach is we should break apart the definition of a derivative. And as we always do, we start simply with things that you should already know, and then we'll just build up from there. So what the derivative is it's the slope of the tangent line. Slope of the tangent line. And it's also known as the rate of growth or rate of change. And they all mean the same thing. They're all synonymous. But the first component of the derivative is that it's a slope. And we should know from previous classes how to calculate a slope. If I write a graph here, or if I draw a graph here, let's say it's 1, 2, 3, 4, and 1, 2, 3, 4. And let's see, can we make that? There we go. No. And so, and so, I'm gonna have some points here on the graph. There we go. I'm trying to get them as close as I can. I won't worry about the first one, but basically, and then this will be a point 0, 0, and this will be point 3, 3. And so pretty much it'll be 0, 0, 1, 1, 2, 2, and 3, 3. Let's see, I think I can kind of, okay, yeah, that's good enough. Okay, so we know how to calculate a slope. It's rise over run. And we pull out this formula in order to calculate the slope here. It comes from the point slope formula. So it's y2 minus y1 over x2 minus x1. And so all we need is 2 points in order to find the slope. And so, in my opinion, the easiest ones to do are 1, 1, and 0, 0. And so we just plug that in. So 1 minus 0 and 1 minus 0. So basically, y2 is 1 and y1 is 0. X2 is 1 and x1 is 0 because we have the point 1, 1 minus 0, 0. 1 minus 0 equals 1, and 1 minus 0 also equals 1. And so this is the slope right here. The slope is 1. And so the function here is f of x equals x. And we can determine this because if we plug in a number, then the function operates on it, we get an input output. So basically, we plug in 0, we get 0 because, we plug in 0 for x, well, 0 equals 0, you know? We plug in 1, we get 1. We plug in 2, we get 2 as an output. So it's 0, 0, 1, 1, 2, 2, and 3, 3. And the slope, as I said, is 1, 1. So that's one way of calculating the slope using this point slope formula, but it's very clunky. It seems like a lot of work. I mean, it's a lot of writing stuff down. Another way of visualizing this is just writing the numbers here 0, 1, 2, 3, 4, and noticing how much they change and by what amount do they change. So as we said before, 0 to 1 is just 1, 1 to 2 is just 1, 2 to 3 is just 1, and 3 to 4 is just 1. Going back to the definition of a derivative, it's the rate of growth. It's the rate of change. So how much are these numbers changing by? 0 to 1 is just 1, 1 to 2 is just 1, 2 to 3 is just 1, and 3 to 4 is just 1. So the rate of change is 1. The slope for the first problem is 1. And this is also f of x because it's just the function. You plug in 0, you get 0 out. You plug in 1, you get 1 out. And if we actually work out the derivative as using calculus techniques, the derivative of f of x, let's see, if f of x equals x, if we actually apply calculus techniques, then then the derivative is also equal to 1. And we say that this is f prime of x. So yeah, if we do it algebraically using the point slope formula, then we get the slope equals 1. And if we just look at it, if we just visualize it on like a number line, then we can say that the rate of change is 1. And if we apply calculus techniques as calculus students, then we know that the derivative of x is a constant, which is 1. So the second component of the definition of a derivative is that it's the tangent line. It's the slope of the tangent line. And what tangent means is that it just intersects the function at one point. So I'm going to have the same function here and have 3 different examples. So tangent just means 1 point. So this is a, wow. Let me try to get that closer. So this is a tangent line. This is a tangent line. That's better. And this is also a tangent line. Hey, that was really good. That was really good. I'm proud of myself. So sometimes in calculus, you'll be asked to calculate the point at which the tangent line equals 0. So that's this thing right here. Because the slope of the tangent line is synonymous with the derivative, which is synonymous with the slope. So it's basically asking, what's the point when the slope equals 0? And we know it's 0 because it's horizontal. Getting back to the problem at hand, sometimes in calculus, you will be asked to compute the point at which the slope of the tangent line, the derivative, equals 0. And let me draw another function right here. Let's say, yeah, let's get there right there. And so, and so this is a really common parabolic function. The function of this is f of x equals x squared. So we have a function, and the first step is to find the derivative, and then we have to set the derivative equal to 0, and then we find x, and then plug in x back into the original equation to find y. So let's work through this step by step. So we said that the equation, or the function, is x squared. And in order to find the derivative, we have to use the power rule. And the power rule is n times x to the power of n minus 1. And so in this example, it's very simple, because the derivative of x squared is just 2x. We put the 2 to the front, and then n minus 1 would be 1. So it's just 2x. And now that we have the derivative, we set the derivative equal to 0. And then we solve this algebraically like a normal equation. 2 times 0 equals 0. And so we find that x equals 0. And then, so now that we have the x component of the point, we have to plug x back into the original equation. So because 0 equals x, we plug in 0. So we say f of 0, let's see, yeah, f of 0 equals 0 squared. And so 0 squared just means, yeah, f of, yeah, 0 squared is just 0, because, yeah, 0 squared is just 0. And so now we have the component when now we have the point at which the slope of the tangent line equals 0. And we can see it graphically right here. That point, which matches this example right here, is 0, 0. So if you found that video helpful, please leave a like and consider leaving a comment as to what other concepts you would like me to cover in this series. And if you enjoyed the video and you thought it was helpful, please consider subscribing for more mathematically related content such as this. Take care and have a good one.